Okay. So our project was a quadcopter. Unfortunately, in the end, it did not work. Ended up crashing and burning. But show you a little bit of what all went on before it kind of crashed and burned. So right here we have the Zigbee, and this lets us communicate from this Dragon board to the Arduino that we have on the copter itself. That code was provided to us, so we didn't have to mess with this communication. What we did have to do was make sure that we could get whatever we want to be the controls from this keypad and get it to the Arduino and make it do what we wanted it to do. So here we also have a 7-segment display for the timer of when the system turns on. So 1 is our system on, so a buzzer will sound and then the timer will start. And then also on the LCD display is like an on command, or an I for on. We also have, if I hit 4 on the keypad, that's displays left on the LCD and the timer's still running. 6 is right, so there's an R for right. 2 is forward. 8 is backwards. A is up. C is down. I hit that twice. And then we have a kill switch where you hit the star and then it'll stop the timer and it will also clear the display. And that in turn will actually kill the motors on the quadcopter so that it's done flying and there's your total time of flight. And then if we hit 1 again, it'll start over and we can do the same thing. Also, another feature that won't be shown is if the quadcopter senses that the battery voltage is too low, it will send a message down here on the LCD that says battery low, and we have to land it soon. And that's it for the Dragon board.
Alright, and then so for the XP chips, when you hit on the keypad, it's going to send a signal from this one to that one on the Arduino, and it's going to send just, a number. And in our code, we have a switch statement that, depending on what that number is, it's going to execute a certain function. Like for example, left, we have it where if in the switch statement the number is left, then the quadcopter will go left. And that's pretty much it.
And within those switch statements, it updates the angle at which it needs to move at. And we have a gyroscope here on our quadcopter. That gyroscope will read angular velocity. So we did some math and converted that into actually the position orientation of the quadcopter. And the Arduino on the quadcopter itself, flight controller, will take the wanted value and then the actual value, and we'll try to make those the same. And that allows us to strafe left, right, forwards, backwards, up, down. That was the goal, at least, but it crashed. And but in order to do that, there's a thing called a PID controller. It's a proportional, integral, and derivative, and it takes in all these values and compensates the overall throttle for each motor, and to determine what the RPMs need to be for each one.
And once you get your signal from the gyroscope and it's compared with the input that you want with each of the motors, you then send a signal through the ESCs that we have attached. The ESCs, they work like a dam. They allow a certain amount of current through depending on what you want to send to the motor. And with greater current, the motor's going to spin faster, and that's pretty much how you get the quadcopter to go.